Hello everyone. Today we shall see one more example on object-oriented programming, that is addition and subtraction of two complex numbers. Now before we go to addition and subtraction of two complex numbers, we need to know what is a complex number. A number which is expressed in the form of a plus bi, where I is square root of minus 1, is called a complex number. I is also called iota, whose value is minus 1, which is totally an imaginary one. A complex number contains two parts, namely real number and imaginary number. A couple of examples to give for complex number is 2 plus 3i, where 2 is a real number and 3i is an imaginary number. Similarly, 10 minus 6i, 10 is a real number and minus 6 is considered to be an imaginary number. So like this we can give you a number of examples for a complex number. So there are various mathematical operations which are possible for the complex numbers, like addition, subtraction, multiplication, as well as division. So today let us see how, using an object-oriented programming concept, add and subtract the two complex numbers. And also we shall see why we require object-oriented programming for representing the complex numbers. Now before going to the programming environment, let us consider two complex numbers, say 2 plus 3i and 6 plus 4i. While adding two complex numbers, the resultant will be the sum of two real numbers as the resultant real number and sum of two imaginary numbers as imaginary number. So in the above example, so what we get is 2 plus 6, which are the real numbers of the two complex numbers, which is equal to 8 as a resultant real number, and 3 plus 4i, 3i plus 4i, which is equal to 7i as imaginary number. So totally the resultant would be 8 plus 7i as an addition after adding 2 plus 3i as well as 6 plus 4i. Similar to addition, we can subtract the two complex numbers. Let's take an example of 6 plus 4i as well as 2 plus 3i. So here also, while subtracting the two complex numbers, we will subtract the two real components and subtract two imaginary components. So in the above example, 6 minus 2 becomes 4 as a real, and 4 minus 3 becomes 1 as an imaginary number. So after subtraction, the resultant is 4 plus 1i. So here we have theoretically added the two complex numbers and subtracted the two complex number. So always before we go for programming, we need to know what is the theory of it. So we have taken examples. Now let us write a program in C++ how to add the two complex numbers as well as how to delete the two complex numbers. Now before going to discuss about the class and the object, we have to confirm why complex number needs to be defined as an object, not as a variable. Let us look into the previous example, wherein You take any complex number, say 6 plus 4i or 2 plus 3i. Whatever example we take, the complex number contains two portions, real number as well as an imaginary component. So there are two components for a complex number. Let us say they are real component and imaginary component. Now it is not possible to declare a complex number using conventional procedure oriented language, that is C. We have to declare or we have to define an object for representing a complex number. So as a part of it, initially let us define a class called complex, wherein I am taking two data elements. What are the two data elements? Real element and imaginary element. So I am defining inside the class called complex with the real as an integer as well as imaginary as an integer. So a complex is a class which contains two data elements, real and imaginary, and in the same class I am declaring the necessary functions under public. So what are the necessary functions under public? First function, get data. Get data is a function to read the values for a complex number. Put data. Put data is another function to display the content of a complex number. Then I'm using add function to add the two complex numbers, and I'm using subtract function to subtract the two complex numbers. Here please make a note, there are four functions which are declared under a class called complex, out of which two functions do not have any arguments, but the later two functions, say add and subtract, have the arguments declared. Why? We shall see in the next example. See, as I mentioned, void get data. So now I am reading the values through a function. How? Void complex scope resolution operator get data. What is the purpose of it? To read the two data elements. What are the two data elements we have declared here? We have declared two data elements. One is real and another one is imaginary. So I am reading the value for real and a value for imaginary. I'll take the previous example. Let me take this example, 6 plus 4i. So here 6 is a real number, 4 is an imaginary number. So now this function get data is a function which will read the contents of the complex number. One real number and another one is imaginary number. So the two numbers are read for a complex number. Now get data is over. Moving on to the next one, that is put data. Put data also we are displaying the two components. What are the two components? Real as well as imaginary. And you may observe, see out real means it is displaying the real value. But when it comes to imaginary, there are plus or minus. So when I add or when I subtract, if imaginary is minus, so in the above example, say here 4i minus 3i, see minus 3 is a value. To represent minus 3, I am using cout imaginary as I. So if imaginary is greater than or equal to 0, straight away I will cout plus I, means real value plus the imaginary value. That means 6 already see out plus as a text message, then 4i text message. So 6 plus 4i. So the output will be in the form of a complex number. So this display or put data is a function which will give the output in the complex number format only. So here I have defined and get data function. Here I have defined the put data function. Now I am left with the calculation part. So what are the two calculations I have? I have two calculations, one to add and another one to subtract. So this function is going to add and this function is going to subtract. Now let us see how this function is going to add. So now I will go to the main program. Here C3, C1, C2 and C3 are declared as complex numbers. Okay, so that means they have the structure of this particular class. So now C3 dot add. C3 dot add. What I'm adding? I'm adding two complex numbers. So that is the reason I am passing the arguments over here. From where? From the main program. So in this example, the arguments which I am passing are C1 and C2. What is C1? It is a complex number. What is C2? It is a complex number. So that is what I am getting it here. So in the function subprogram, void complex scope resolution operator add, I am taking two complex numbers from the main program. That is why I declare the arguments C1 and C2 of type complex, because from the main program I am supplying the complex numbers to the function subprogram. Okay, I have taken two complex numbers C1 and C2. What is the addition? So how does the complex number gets added? Like how A is added with B to get C. So real number is added with this real number. Imaginary number will be added with imaginary number. So how many complex numbers I am taking from the main program? I am taking two complex numbers. What are they? C1 and C2. In this example, C1 and C2 is C3. So I am getting C1 and C2 from main program. What are the two components of C1? C1 dot real is one component and C1 dot imaginary is another component. Similarly, I have C2 dot real is one component, C2 dot imaginary is another component. So now let us add the two complex numbers. How do we add? The real part is nothing but the real part of first complex number plus real part of second complex number. That's why C1 dot real plus C2 dot real. So here I am adding two real numbers, C1 dot real and C2 dot real. Similarly, imaginary number is equal to imaginary number of the first complex number plus imaginary number of the second complex number. So resultant will be C1 dot real plus C2 dot real as a real number, C1 dot imaginary plus C2 dot imaginary as an imaginary number. This is how the addition function works. Coming to subtraction, exactly similar to addition function, but here operation is minus in the place of plus. Here also the function takes the two complex numbers from the main program. That's why there are two arguments in the function subprogram in the name of complex number, complex C1, complex C2. So here real is equal to C1 dot real minus C2 dot real, and similarly imaginary is equal to C1 dot imaginary minus C2 dot imaginary. So in this slide we have seen the four functions of the class. What are the four functions? Get data, to read the values to the complex number, display, to display the complex number. It may be whatever complex number you have read, or it may be the resultant after adding or after subtracting. So whatever complex number you have, this particular function is going to display the complex number in the complex format only, that is a plus bi format only. Now let us go to the main program. See, in the main program I have declared three objects C1, C2 and C3 of complex. Okay. Now I am reading the first complex number C1. C1 dot get data. The moment I write C1 dot get data, the control transfers to this, wherein it will read a real number, let us say 6. It will read an imaginary number, let us say 4. So C1 will be 6 plus 4i. Then C1 dot put data. So you will get 6 plus 4i as C1, because this function for C1, which is a complex number, will be executed. Now I am reading the second complex number, that is C2. C2 dot get data. Let us say 4 as a real number and 2 as an imaginary number. So 6 as a real number in the previous case, 4 as a real imaginary number in the previous case. But coming to second object, that is a C2, 4 is a real number and 2 is an imaginary number. So C1 is read, C2 is read, both of the complex numbers are displayed. Now my job is to add the two complex numbers. So see out, sum of the complex numbers is, so you add C3 dot add C1 comma C2, means C3 is a complex number which is the resultant after adding C1 and C2. C1 is a complex number having 6 plus 4i as its value. C2 is a complex number having 4 plus 2i as values. So both of them will be added by executing this. 6 plus 4, real number becomes 10. So 4 plus 2, real number becomes 6. So C3 becomes 10 plus 6i as a resultant. So this 10 plus 6i will be displayed on the system. Now difference of the complex numbers. So now you are executing C3 dot sub of C1 comma C2. C1 is 6 plus 4i, C2 is 4 plus 2i. Now this arguments are passed via here. Real is equal to C1 dot real, that is 6, minus C2 dot real, that is 4. So output real becomes 2. Similarly imaginary, C1 dot imaginary, which is 4, and C2 dot imaginary, which is 2. So 4 minus 2 becomes 2. So now after subtraction, C3 becomes 2 plus 2i. So that is displayed, and get ch, your program is now terminated. Now you will get an output something like this. Enter the first complex number. See, enter the first complex number. So you are reading the real part as 2, imaginary part as 1. Real part as 1, part 2, imaginary part 3. So enter the imaginary part 3. So now 2 plus 3i is the first complex number. Now see out, enter the second complex number. So when you say enter the second complex number, so it goes to the function wherein you are entering the real part as 2 and you are entering the imaginary part as 1. So 2 plus 1i is the second complex number. Now after addition, output becomes 4 plus 4i, and after subtraction, the output becomes 0 plus 2i. So this is the output. I hope you have understood this program, and go through this program, try this program by manually executing this program. Then you'll understand the logic, and then you can do the program without any difficulties. Thank you. Let's see once again.